Hello students. In the last video we have discussed the modifications and variations of Turing machines, and in this video we'll discuss the Turing machine as an enumerator. Right? What does it mean? Enumerations. Okay. See, we can say that a language is recognizable by the Turing machine if and only if there exists some enumerator to it. Right? We are not doing always, but inherently there must exist some enumerator. What is it? Right? See, enumerator is a Turing machine with an output printer. That is a simple definition of the enumerator. But what it will do, right? We use this printer as the output device to print the strings. For example, here we are having write-only tape, and this finite control unit will work on it and print the output. That's it. So whatever the end user is seeing, that is only on this write only one step. This would be used as a printing tape or printer, and whatever you are doing the task, that you can do it in the working tape, right? So let me go with this. The language accepted by the enumerator E is nothing but the collection of strings that eventually prints out. Means whatever the strings printed on this output type, that is nothing but the language accepted by it. So it will generate the strings in an order. Sometimes it may repeat the strings also. And see, you cannot give any input to the enumerator, and if the enumerating TM does not halt, then definitely it is going to print the infinite number of strings. Means, see guys, listen here, if you have constructing an enumerator and you are not giving any input string, when you start the process, right, so then it will print the strings. Sometimes it will print few strings and it will halt it after that. Sometimes what will be happen, it is not going to print any string, right? We can say that reject, but it will be halted. So in some cases what will be happen, it will enter into the infinite looping. Means we are saying that halting problem, Turing machine halting problem, it won't halt for it. Okay? We'll discuss about this halting problem clearly with other examples. So in this case it will print some strings which are going to be recognized by the enumerator. In this case it won't print any strings, so that the language accepted by the enumerator is empty. But in this case it won't stop and keep on printing the input strings. We don't know what it would be, right? Then what is the definition of the enumerator here? So enumerator is a 6 tuple notation. The Q is nothing but the finite number of states, and sigma here it is the print type alphabet and not containing even the blank symbol. Right? Print type alphabet, it's not input type, print type, what we are going to print it on, right? Then the work type alphabet, we are going to have the blank, and even it is subset, the input print type alphabet is also subset of this work type alphabet. We don't have any input type here, only work type and print type. That's why here we clearly mention that there is no input to an enumerator. And what is the transition function here? On any state, if you read any print type alphabet and a particular work type alphabet, here we are having three things. This is the current state, and this is print alphabet, and this is work type alphabet. So on a state, if you read any particular print alphabet on a particular work type alphabet, then it will give you the next state and it will print some symbol on it and it will specify the direction. So this is regarding the print type. Then but we are having one more like work type, right? Then in work type what you are doing it and which direction you have to move in the work type. So this will be having the two type device, because we are having the print type and also we are having work type. So you have to mention what we are doing with this print type and what we are doing this work type, and which direction you are moving here, which direction you are moving here. Those two things you have to specify here, right? And of course Q naught is nothing but the initial state, and Q print is the final state. If you reach that, then it is going to give you the output of it, right? Then let me go with the example of here, the enumerator. See, a language is Turing recognizable if and only if there must be some enumerator. Okay. Then what will be happened here? A power n, b power n means it would be epsilon 1a, 1b, 2a's, 2b's, 3a's, 3b's. So it is going to take all the strings possible. Let S1, S2, S3 be the list of all possible strings in sigma star. Means all the possible strings with the a comma b. Then we have to construct an enumerator which is going to generate a sequence for only this language. Now we have to construct an enumerator to generate this language. Then how it will work, right? As follows. Repeat the following steps for I 1, 2, 3 because here it is having n greater than or equivalent to 0. Then you have to repeat it. So run m for steps and each input S1, S2, S3. So for every string you have to do it. If any computation is accepted, print the output corresponding to Sj. Right? Then what we are saying that if epsilon, right, the sigma star is having like this, epsilon a b, right, a b b, right, a, so on like that. Now you have to construct an enumerator which will work on each and every string in the sigma star. This is a universal language, right? Then run m mission for the first string. If it is satisfying this condition, that will be printed. Otherwise, it will go for the next input string. Same way, it will do it in order. It is not going to miss the order, guys. It will go in an order. Then again, the enumerator will run on this A. If it is accepted or satisfying this language condition, it will be printed. Otherwise, it will go to the next one. So it is going to move on to the each and every string in the universal language, right, which are satisfying the condition. So this is about Turing machine as enumerator. So if you are saying that some language is recognized by the Turing machine, as I told you that there must be some enumerator to enumerate it. It is not the language recognizer, guys, right? So you have to construct some machine and also the enumerator. Then it will show you whether the strings, whatever you meant for the language, is accepted by that, or is it satisfying that language or not. Okay, so these two steps you have to follow here. For every string you have to run it, and if any computation is accepted, print out corresponding to Sj. Sj means the strings. If m accepts a particular string s, it eventually appear on the list generated by the enumerators, of which is going to be print out. Okay, so in the next video we'll discuss about restricted Turing machines. See, we have discussed about modified Turing machines. We have discussed about variations of Turing machine. Modification means to the standard Turing machine, what are the changes we have made. And there's no right variations means we are adding some other extra like tape, add, dimensions. Variations means adding some new features to it. Modification means changing some functions. Restricted means we are putting some conditions to the Turing machine, like you should not go there, you should not do this. Like we are keeping some restrictions on either tape or head or finite control unit, whatever it is. So those things we will discuss in the next video.